So far we've been looking at the movement of this white-tailed deer in the context of the 2015 NAPE imagery. The data runs from 2013 to 2015, so this image is as close as possible to the landscape as she experienced it in terms of forced harvest patterns and other conditions, like if she was spending time in hardwood stands, softwood stands, or mixed wood stands. Now I'd like to show you some things we can do with the elevation model that might help you interpret or at least develop some hypotheses about what she's doing on the landscape and why. So I'm going to uncheck NAPE 2015, and we still have our 10-meter resolution digital elevation model from the first week. I like the way this is displayed, so I don't want to change it. So instead, I'm going to right-click and say Duplicate Layer. And that doesn't copy and paste the entire data set. You still only have one copy of the underlying data. What these layers are a set of instructions of how to display that underlying data without modifying the thing itself. Now I can uncheck this, check this one on, and now whatever I do will apply to this copy, and I still have the same set of instructions of how to display according to elevation within the range displayed. So again, highest elevation value gets white, lowest elevation value gets black, no matter how far I zoom in or out. The first thing I want to show you is contour lines. So let's move back so we can see all of her range here. And I'm going to right-click and go to Properties, can also double-click on that. And I'm going to change the render type here. So Render Type, Contours. And I have the choice of contour interval. And this was originally a 20-foot contour interval. So I'm going to go ahead and do that with an index contour every 500 feet. So when I say this was originally a 20-foot contour interval, this digital elevation model was created from contour lines that were originally developed for the NTS topo maps. So it's very easy to go from contour lines into a raster digital elevation model or back the other way, which is what we're doing now. So we have a raster digital elevation model and we're going to display it as contours without actually creating a new data set. So let's go ahead and say apply here and see how we like it. So 20-foot contours, there we are, very good. And we can change their color if we so choose. Let's try a nice bright yellow because that stands out well against an air photo. Does not stand out well against a white background, but you can also select a recent color here. But we have the option of displaying the air photo beneath the contour lines. So now we have both, and we can zoom right in here and see that she is spending an awful lot of her time on the west-facing slope of this hill, as well as on the south and southwest-facing slope adjacent to this road. We can see the same thing in terms of where she is on the hill using the digital elevation model, but we can't see that as a good overlay with an air photo, so that's where the contours come in. Another thing we can do with the digital elevation model, and I'm going to make another copy here, so right-click, duplicate layer, and I'm going to turn that one on, and I'm going to turn our deer off for now. So right now this is just showing plain elevation. This goes from a lower elevation here to a higher elevation here, and again we have the numbers here, so the highest value is 472 meters, and the lowest is 247. I changed that. The lowest is still 247, but the highest is now 557. That's just plain elevation. Let's try a hillshade. Right-click, Properties, Render Type, Hillshade. This altitude 45 degrees and azimuth 315 degrees refers to the sort of hypothetical light source, or the imaginary light source. So picture a feature here with a flashlight held here, that's 315 degrees, so we'd have 0 or 360 degrees here, 180 degrees here, 270 degrees here, and here is 315 degrees. The altitude, 45 degrees, that refers to the angle of the light coming down from there, so about halfway, where perfectly flat across the landscape would be 0 degrees and pointing straight down would be 90 degrees, so 45, picture that flashlight being held at a 45 degree angle. Move that a little bit so you can see, and apply. So as if a flashlight was held here. So that's the classic hillshade, one source of light. We also have the option to use a multi-directional hillshade, which uses multiple sources of light, using an algorithm to predict which would be the best. Apply. So there you see a different way of looking at that terrain. The z factor exaggerates whatever differences are actually on the ground. So when you think of coordinates, you have an x and a y coordinate, or a latitude and a longitude coordinate, and you also have an elevation. That elevation is the z coordinate. Let's try exaggerating that. Change that to 2, apply. You see how that changes the color contrast here, how everything starts to pop out. Let's go to 3, apply. We're going to be too much now. Let's go all the way up to 7. Much too much. But 2 is usually pretty good for a hillshade. Now let's use that as background to look at our deer data. Okay, there's deer 19. So she's hanging out on that slope, which is fairly steep here. And let's see. So she doesn't seem to spend a whole lot of time right on that steepest part there. Why might that be? So we can look at our hillshade and then our actual image back and forth. And maybe we can come up with a hypothesis about why she's not seeming to use this area very much at all. Maybe our hypothesis is slope. We need to create a slope model and see is she using steep ground or not. So raster, analysis, slope. Input layer is the state 10 meter DEM, and any of these will do, but I'm going to go with the original there. And the ratio of vertical units to horizontal is by default 1 and should remain so unless there's a good reason otherwise. I do like to have the slope expressed as percent instead of degrees, so that's easily calculated by rise over run, so that's what we normally use. And that's really all it needs, so I'm just going to hit run and we'll wait for a little while. And 86 seconds later we have a completed slope model. Close. Let's uncheck deer 19 and have a look at our model itself, which is defaulting to black and white, but that's not ideal. So let's double click there, can also right click properties, and change the render type here. Let's change that to single band pseudo color. Green to red is a good color ramp to use, but we want to invert that because, of course, lower slope, green, good. Higher slope, red, potentially dangerous, is a good intuitive color scheme. So that's what the default looks like when applied. Let's change this interpolation from linear to discrete. That allows us to change these values and how they're displayed. So we have less than or equal to 50% slope displaying as green, 50 to 100% slope as this lighter green. Let's apply that and see how it looks. It looks like a bunch of nonsense because almost everywhere on the landscape is less than 50% slope. So we change it to something that makes sense. Let's start, double click, 2. Less than 2, we're actually going to change this color scheme. Less than 2 we're going to display as a blue because less than 2% slope is not likely to move water very much, therefore it might be wet. And let's change the next range down from 2 to 100% slope. Also kind of silly. Let's see how it looks. Apply. So there you go, the shallow slope, and then everything else on the landscape. 2 to 10 would make a lot more sense than 2 to 100, so let's change that from 2 to 10, and you see that's changed the next one down as well. Apply. There's our 10% slopes. But this yellow here is from 10 to 151%. That's a bit much, so let's make that 20. Apply. So there's our 20% slopes from 10 to 20. Now if we just change this one to 30, that changes from 20 to 30 and then greater than 30% slope. So now we have relatively flat ground that might not shed water very well at all, might accumulate water and remain wet, and then from steep enough to drain somewhat to 10%, which is not a particularly steep slope, then 10 to 20, 20 to 30, greater than 30. Apply. So now we've classified our landscape into different slope classes. Now we can hit OK and turn our deer data back on and see if we zoom in here. She's using some of these steeper slopes, but not other areas over here, so slope itself does not seem to explain what it is that she's using. Unless she cares about something that's much steeper. So let's try a little change to this classification. So let's make that 30 and make that, change that to 50, see what that does, apply. So there's greater than 50% slopes, and she's still using even some of those. So that doesn't seem to be a good explanatory variable, to what it is that she's doing and using on the landscape. So I'm just going to set this back as it was to 10, 20, 30, and greater than 30. There it is. Zoom out a little bit. And now we can look at this against the air photo again. So there's the air photo, there's the slope model. So let's zoom in here so we can see, and we can go back and forth, look and see what is she using and why. At this point we still don't really seem to know, just looking at the broad patterns of total usage. Looks like we have some hardwood here, an open clearing here, where she spends a lot of time, some usage down here. Looks like she's spending a lot of time in this other opening that looks like it might be a little bit different composition or density than here. See the difference in color between this area and this one. And of course, you know we're not going to find a final answer from this, but this does help us form hypotheses and questions we might ask in the field if this wasn't in Quebec and we could go and easily access that. But let's go back to our elevation in Hillshade. So there's our slope. Very nice. Keep that for later. But we also have our hillshade and our contour lines. Now you could just put the contour lines on top of the hillshade and look at it that way. And you can see where the contour lines are closer together, it's steeper, the hillshade is showing a darker color, which is a good visualization of that terrain. But we can also set some transparency to our digital elevation model itself, use color to display elevation, and have both elevation and hillshade displaying together. So I'm going to duplicate this layer again so I can keep my original, but I want that to be just on top of everything else. Come on, you can do it. Oh, there it is. Very good. So I'm going to duplicate this layer again, right click, duplicate layer, and I'm going to move that down here so it's just on top of the others. So I'm going to work with this one, check that on, see how that's overwhelming the hillshade. So of course it's on top, and there's no transparency. So let's fix that first. So just under symbology here on the left, we have transparency. I'm going to try setting that to 50% to start. I can use the slider, or I could just type it in there. Apply. Now you see the problem here. We have hillshade showing shades of gray from black to white, and we also have elevation showing in shades of gray from black to white. That's not going to work. Back to the Symbology tab and render type single band gray to single band pseudo color. And then we have our choices of color ramp, and let's go ahead and start with spectral. There we go, and that goes from red to blue. Let's just try that out, apply. But maybe we prefer to invert the color ramp, apply, and that makes a bit more sense. And we can pop open the min-max value settings and the statistics extent to our updated canvas again. Apply. Now let's hit OK and see if that works. There we go, it does. So now we have a blend of hillshade, so you see the differences in the shading here, with elevation displaying as before, with the lower value being on the lower end of this color ramp, and the higher value being on the higher end of that color ramp. That makes our contours redundant, of course, so we can uncheck those, and now we just have our terrain and elevation together. Let's uncheck our deer data, just zoom out to look at more of the landscape. This can make a very beautiful map. Zooming out a little bit more, so now we can see the whole terrain of the central ridge in Aroostook County. There's Katahdin down there. And we have this ridge here, we have the St. John Valley here, we have the Allagash and the St. John. The St. Francis up here, Bow Lake and Glacier Lake. Now we can pop down in here a little bit more. We see still have one of these deer data points selected. We can clear that selection and then turn all of our deer data back on and see the terrain that she crossed. And we can do some things to make this nicer. Let's try adjusting the brightness and contrast. So let's turn up the brightness or the contrast by 10, see what that does. Not bad. Let's turn up the brightness by 10. Apply, not bad. And the saturation looks like a bit much now, so let's make that -10. See how that does. Not bad at all. And the intended purpose of the map really drives how you symbolize elevation. If you want the elevation to pop, to really be the main subject of the map, then you do something like this. But sometimes you want it to sort of fade into the background. You want it to be there when you look for it, but not really grab the eye. So let's change the transparency and demonstrate that. So I'm going to set that to be 30%. So there's that. And now the hillshade is kind of overwhelming, so I have to set transparency on the hillshade as well. So I'm going to set that to try 50%, apply. That's not bad. So now you see how these data points, they pop out more. The elevation is still there if you need to look for it, but it's not hitting you in the face. It's not grabbing your eye first. This is the subject of the map. This is other information that's there if you need it and if you want to look for it for context. Let's look at the wider landscape again that way. So there is the whole northern part of the state of Maine. Here is central Aroostook. So if you were to put other layers on top of this, once it loads up, you could see those layers much more clearly because this is not the dominant feature of the map. The same view as it was just before, this is now a very dominant feature of the map. It grabs the eye. So we can zoom out here, look again. Let's zoom in. So I don't want to see Katahdin because that being the highest point really changes how all the colors display. Let's zoom in just a touch more. I'm just going to move that so Katahdin is out of the way. And same for those hills there. Mountains, to be fair. So now we can see the difference in elevation between most of the North Maine woods and most of this area down towards Presque Isle and Caribou down here. This is a very different landscape from up here to down here. Different elevation, different temperature, different soil type as well. And considering our deer again, that is the portion of the landscape that she used between 2013 and 2015. We can also turn our townships layer on and see she used 1, 2, 3, 4 townships plus part of Quebec. Adding our streams layer in, we can zoom in and see that she crossed, it looks like 1 or 2, then 1, 2, 3, 4, 5, 6, 7 streams on her way in between her wintering range and her summering range. We can also look at the Maine Conserved Lands layer and the Maine BPL Public Lands layer and see that she was using some of our public land here. And she also crossed one of these major conservation easements, and we can use our Identify Features tool on the Maine Conserved Lands layer to identify who holds that, which is the New England Forestry Foundation. And looking at their GAP status, permanently secured for multiple uses and in natural cover. Now I don't know the details of that agreement, but that would seem to preclude any kind of farming or permanent settlement. Wouldn't know about camps. Maybe yes, maybe no. But the interesting thing here is we can see the scale of her use of the landscape and the scale of these conservation efforts. If you've been through my Intro to Forestry class or done your own research on the topic, you know conservation is one of the bedrock principles of forest management. That philosophy goes back more than a century and is part of our modern code of ethics. Part of that is maintaining habitat suitable for the native species, and we can see here that she is using these recently harvested areas. So they do not preclude her use, and they may actually give her some benefits, like easy access to browse, twigs, shrubs, small trees. But the question is, and the question we can't really address with one deer color to work with, is there anything on the landscape that she is missing? Is there anything that she would have had 200 years ago that is not present now? One of the obvious answers is there's about 1.5 million acres of spruce fir forest that is simply not there anymore. That 1.5 million acre figure comes from this inventory beginning in 1982, looking at the large diameter, medium diameter, and small diameter spruce fir, where in 1982 we had 4 million acres in large diameter spruce fir sawtimber, and that was reduced by about 2 million acres in the course of the spruce budworm outbreak. By 1995, that loss was apparent and has declined somewhat since. Medium diameter spruce and fir down about 1 million acres with a minor upwards trend in 2013. Small diameter spruce and fir up about 1.5 million acres. So we're down 2 million here, 1 million here, up 1.5 million here, which adds up to a loss of 1.5 million acres of the spruce fir forest type. That's mirrored by gains in the small diameter size class of the aspen birch type, and also gains in the shade tolerant hardwoods, which include beech, with a large portion of that beech being affected by the beech bark disease in such a way that it will never produce the mast beech nuts that it did in the past. But about 1% have some genetic resistance, and those are, as they ought to be, conserved. I do like to hear about it when you find clear beech, and if it's clear and over 8 inches, that's meaningful. If it's less than 8 inches, sometimes the small ones just don't get it yet. This figure is not looking at the total number of acres, but the volume per acre of the spruce fir type, looking at the red spruce alone. And in this we can see the northern megaregion has suffered the sharpest loss. This is the publication, Maine Forest 2013. Strongly encourage anybody interested to read through the whole thing, and there is a new update with the 2018 inventory in draft form coming soon. Anyway, why would that loss matter to a deer? Deer winter in typically softwood-dominated stands, so mature softwood catches the snow, keeps the snow off the ground, and improves the mobility prospects of the deer. So if the snow is not too deep, the deer can walk around. If the snow is too deep, well, it essentially gets bogged down, high centers, and can't move around so well. And if it's too deep, they simply starve to death. There are state-designated deer yards, and there are cooperative agreements with adjacent landowners to further improve the areas that are not specifically in state-regulated deer yards, but are nearby and potentially used. But this area here, there may be a food source available to her here. And if you've driven through here, you know there's a certain amount of food that finds its way onto the ground for them. That is perfectly legal outside of deer season, and there's some guidance here from Maine IF&W. That's available online if you just Google that title. One last thing to show you with the digital elevation model, or what you can do with it, or what you can derive from it before I turn you loose on this data set. Let's go under Raster, Analysis, Aspect, and that's going to tell you which direction the slope is facing, if it's a south-facing slope or a north-facing slope. The input layer is our statewide 10-meter DEM, and I'm going to make just a temporary layer. That's all it really needs, so go ahead and run. 82 seconds later, we have the aspect model. Now I should note, I have a very fast computer. Yours is probably going to take about 10 times longer than this, so it's a good time to take a break, take a walk, grab lunch. So here we have an aspect model from 0 to 360 degrees. Let's go ahead and change that to a single band pseudo color. This linear interpolation really doesn't work at all, so let's change that to discrete. And here we have to remember that we're looking at degrees essentially on the compass, so from 0 to 360 degrees. So we actually want the lowest numbers to have the same number as the highest numbers, because 359 degrees and 1 degree are actually just 2 degrees apart. So I've set this to 45 and this to 315. So above 315 and below 45, I want those to have the same value. I'm going to use the color picker, sample color, and I can just point that at whatever I want to match, and there it is. So now those have the same color. I want another 90 degree swath here, so 90 plus 45 here means the next one should be at 135. 90 degrees more is 225. Let's go ahead and apply that. And now we've broken up our whole landscape as to whether it's pointing generally north, generally south, or generally east or west. So 0 is the middle of this red range, 90 due east is the middle of this range, 180 due south, the middle of this range, and 180 due west, the middle of that range. Okay, and now let's uncheck our Maine conserved lands and Maine BPL lands, and we can see that in her summer range up here, we've moved ourselves down there, she is usually on the west-facing slopes or the south-facing slopes, and occasionally on the north. And she's also using a west-facing slope here, and looks like a south-facing and east-facing slope here. Whereas in town, she's spending a lot of time on north-facing slopes, but she also has access to some south-facing and east-facing slopes here. But we can also see this is not very steep ground here. See, I've checked on our contour lines again. You see the distance between those. It looks like pretty flat ground. So while this is showing that it's a north-facing slope, it's not a very steep slope, and that slope might not be blocking the sunlight at all. Later on in the course, we'll talk about how to create a solar radiation model that will estimate the actual number of hours and when the sunlight hits a particular spot. For now, I'll turn you loose on all these data sets and what you can derive from them as demonstrated to generate hypotheses about how and why this deer is moving and acting as she does on the landscape. Any test of those hypotheses would take much more data than we have here, but this is a great data set to start with by way of observation. Remember, this is a 9 or 10-year-old female white-tailed deer with GPS fixes about every 3 hours.